Hello, and welcome back to our Spring Boot tutorial series. Today, we're diving into a fundamental aspect of Spring Boot: Java configuration, specifically focusing on the @bean and @configuration annotations. By the end of this video, you'll understand how to use these annotations to define beans in a Spring application context. Let's get started. Let's quickly recap what Java configuration in Spring Boot is all about. Spring Boot gives us the awesome flexibility to configure beans using Java-based configuration. So, instead of dealing with those old-school XML files, we can define our beans directly in our Java classes. This not only makes our code more readable but also takes advantage of Java's type safety, making our code cleaner, more efficient, and a breeze to maintain. Up until now, we've been using annotation-based configuration. While it's powerful and convenient, today we're going to explore another fantastic approach that Spring Boot offers. You might be thinking, why do we need Java-based configuration when annotations seem to do the job just fine? Don't worry, we'll break it all down and explain everything in this video. Before we dive in, let's take a moment to clean up some of the code we used in our last video. This will help us start fresh and make everything easier to follow. Next, let's open the English Greeting Service class and remove the @scope annotation. Now, let's move on to the Greeting Service controller. Open it up and remove the application context variable. Instead, add a new variable of type Greeting Service named Greeting Service. Also, update the constructor to handle this new injection method. This will ensure that our service is properly wired up and ready to use. Next, let's clean up the getGreeting method. Remove everything from it and simply call the getGreeting method of Greeting Service, returning its response. Let's open the English Greeting Service class. As you can see, the English Greeting Service class is currently annotated with the @component annotation. This annotation tells Spring to create a bean for this class. Now, let's explore a different approach, using Java-based configuration to create a bean for English Greeting Service instead of relying on annotations. Alright, let's take the first step in our new approach by removing the @component annotation from the English Greeting Service class. So, what happens now if we try to start the application? As you might remember from our previous videos in this tutorial series, the server won't start. Why? Because the Greeting Service controller needs an English Greeting Service bean, and we just removed it. Let's start the application to verify what happens. As we can see, our application didn't start successfully. Let's scroll up in the console log to see the reason behind this issue. As we see in the logs, Greeting Controller requires a bean of type English Greeting Service, but it couldn't be found. Let's solve this problem by creating a bean for English Greeting Service using Java configuration. First, let's create a new package called config. This package will house all our Java-based configuration classes. Next, let's create a new class inside the config package and name it Greeting Service Config. This class will be the centerpiece of our Java-based configuration, where we'll define the beans for our application. Now, let's annotate this class with @configuration. This annotation tells Spring that this class contains one or more bean definitions, which will be managed by the Spring container. Essentially, it transforms our class into a source of bean definitions, making it a key part of our Java-based configuration setup. Next, let's create a bean for English Greeting Service. First, we'll create a method named English Greeting Service that returns an English Greeting Service object. This method will be responsible for instantiating and providing our English Greeting Service bean. Inside this method, we'll create an object of English Greeting Service using the new operator and return it. This way, Spring knows how to instantiate our English greeting service bean when needed. But wait, just defining a method isn't enough for Spring to create a bean from it. We need to give Spring a bit more information. Specifically, we need to tell Spring to treat this method as a bean definition and execute it to get our bean. To do this, Spring provides the @bean annotation. So, let's annotate our English greeting service method with @bean. This annotation tells Spring that this method will return an object that should be registered as a bean in the Spring application context. But wait, what about the bean name? We haven't specified it yet. If we don't specify a bean name, Spring will use the method name as the bean name. So, in this case, the bean name would be English greeting service. But what if we want a different name, like English greeting service 1? In that case, we need to specify the bean name as a parameter inside the @bean annotation. Now that we've set up our Java-based configuration and defined our bean, let's restart the application to see our changes in action. As we can see in the logs, our English greeting service object has been successfully created. Spring also called the @postConstruct method of this bean, indicating that our Java-based configuration is working perfectly. This demonstrates how Spring initializes and manages our beans, ensuring everything is set up correctly before the application starts. In the greeting controller class, we've injected the English greeting service bean. Now, let's check if it's been injected properly by opening our web browser and accessing the appropriate endpoint. This will confirm that our configuration is working as expected and that the bean is being correctly utilized within our application. Type localhost 8080/greeting into your web browser's address bar and press enter. As we can see, we received the expected response, hello. This confirms that our greeting controller is properly using the injected English greeting service bean. Everything is working perfectly. Now, let's check if Spring will manage our @predestroy method. Since we didn't specify any scope for our bean, it defaults to singleton scope. For singleton scope beans, Spring manages both @postConstruct and @predestroy methods. So, let's stop the application and see if our @predestroy method gets called properly. As we can see in the logs, our @predestroy method was successfully called when we stopped the application. This confirms that Spring is effectively managing the lifecycle of our singleton scope bean, handling both initialization and cleanup. Also, note how we used the @bean annotation to explicitly define our bean. This annotation not only allowed us to customize the bean's name but also confirmed that Spring is managing the lifecycle methods like @postConstruct and @predestroy for our singleton scope bean. It's great to see how Spring takes care of these details for us. Using the @component annotation, we created just one bean of English greeting service. But what if we have two different English greeting templates and we want to show one template to one set of users and the other template to another set of users? You might wonder if this can be achieved using @component. Unfortunately, @component doesn't allow for the creation of multiple beans of the same type with different configurations. However, you can achieve this using the @bean annotation. By defining multiple @bean methods, each returning a different instance of English greeting service, you can tailor the service to different needs. This approach provides great flexibility and allows you to manage multiple beans of the same type with ease. In one of the earlier videos of this tutorial series, we learned how to change the scope of a bean using the @scope annotation along with the @component annotation. Now that we're defining our bean using Java configuration, you might be wondering if we can still change the bean's scope. The answer is yes. Just like before, we can change the scope of our bean using the @scope annotation. Instead of annotating the class, we simply add the @scope annotation directly above our @bean method. This allows us to specify whether the bean should be singleton, prototype, or any other scope supported by Spring. Let's annotate our English greeting service method with the @scope annotation and change the scope to prototype. As we know, for prototype scope beans, Spring manages the @postConstruct method but does not manage the @predestroy method. We learned about this behavior in our last video. By setting the scope to prototype, Spring will create a new instance of English greeting service each time it is requested. As we injected the English greeting service bean into the greeting controller constructor, its scope is now set to prototype. This means that Spring will create a new instance of English greeting service each time it is requested. However, since the greeting controller itself is a singleton, Spring will inject a new instance of English greeting service only when the greeting controller is instantiated. Let's start the application and see our changes in action. As we can see in the logs, the English greeting service object has been successfully created, and Spring has also called its atPostConstruct method. This confirms that Spring is properly managing the lifecycle of our prototype scope bean, initializing it correctly each time it is requested, even though the object is created using the @bean annotation. As we know, Spring doesn't call the @predestroy method for prototype scope beans. This is because Spring only manages the destruction lifecycle of singleton beans. Let's observe this behavior by stopping our application and checking the logs. Let's stop the application. As we see in the logs, our @predestroy method is not called. This means that when creating a bean using the @bean annotation, Spring manages the bean's lifecycle properly according to its scope. So, when should you use the @bean annotation? Here are some key scenarios. 1 is complex bean definitions. When creating beans involves complex logic or requires constructor arguments, @bean allows you to handle this in Java code. For example, configuring a data source with specific settings. Next is external libraries. When working with third-party libraries that are not Spring aware, @bean can integrate these components into your Spring context. For example, configuring AWS beans for S3 client or secrets manager. Another scenario is multiple instances. If you need multiple instances of the same type with different configurations, defining multiple @bean methods can help you manage this efficiently. For example, creating different greeting services for various templates. Then there's legacy code. When dealing with legacy code that cannot be easily annotated with Spring stereotypes like @component, @bean provides a way to include these classes in your Spring configuration. Finally, programmatic configuration. For cases where programmatic configuration is preferred over annotations, using @bean within a @configuration class gives you the full power of Java to define your beans. Using @bean allows you to leverage Spring's dependency injection while maintaining full control over bean instantiation and configuration. Using the @bean annotation in Spring Boot gives you a powerful and flexible way to manage your beans. Whether you need complex bean definitions, integration with external libraries, multiple instances of the same type, support for legacy code, or prefer programmatic configuration, @bean has you covered. Thank you for watching. If you found this video helpful, please give it a thumbs up. Don't forget to subscribe to our channel for more tutorials on Spring Boot and other exciting topics. Hit the bell icon to get notified whenever we upload new content. See you in the next video.